Okay, this is the introduction to Chapter 8, which is dealing with chemical equations and chemical reactions in general. So overall, in this particular chapter, we are going to look at writing chemical reactions and being able to predict products when we're all said and done. Okay, so this particular VodCast is the first step in that, dealing with balancing equations. Okay, so Chapter 8 is entitled Chemical Equations and Reactions, and it really is the next logical step to where we've been. If you look at where we've been, okay, we started out the year looking at properties of matter. Then we looked at the atoms and the fact that they're made of protons, neutrons, and electrons. And then we started looking at how those electrons were arranged, because we have learned in the chemical bonding section that the bonding of those atoms depends on where electrons are located. We did a lot with the periodic table, so we are getting very used to that. And we have now just dealt with a lot of naming and writing formulas. So our next logical step really is, okay, starting to put all this together into chemical reactions. Now, the first thing we need to do is kind of define what a chemical equation is. We've been writing chemical formulas up to this point. Now we need to write equations. The equation is an expression that shows compounds and amounts that are reacting in terms of atoms or moles. A couple of terms that you're going to see and hear a lot is you're going to hear the terms reactants, and you're going to hear the term yield products. Okay? Reactants are the things that are reacting, and products are what are produced. In chemistry, what we do to use or you represent the yield sign is an arrow. Okay? So, reactants are the substances that are reacting. And it actually doesn't have to be two things. It could be one thing that's actually decomposing, and that's a type of reaction called a decomposition, and we'll get to that. But reactants are what are reacting, and products are what are produced. Now, there are three basic requirements for writing an equation. First of all, the equation must represent known facts. The known facts, you either go to a lab, put two things together and see what happens, and look at the analysis of that, or you find them in a book. Okay, so either lab analysis or a book, but equations must represent known facts. Secondly, you must have formulas written correctly in equations. Okay, that's why we've done the whole chapter on writing formulas. If you cannot write formulas yet, you are still going to be in trouble, and you're still going to have to learn how to do that. So as an example here, barium hydroxide is not just BaOH. You have to remember that hydroxide is a -1, barium is a +2. So the real correct formula is BaOH2. The other thing that's going to happen to us a lot is you are going to have single elements. And when you have single elements in a reaction, you just write them as the element symbol. So aluminum is just Al, iron is just zinc. And then the third thing that's going to happen is you are also going to have diatomics. And you have to remember what the 7 diatomics are, and the fact that those 7 diatomics must be written correctly. So when you come across oxygen, okay, you don't just write O. If the reaction says something reacts with oxygen, it is O2. Okay, and you'll find this with hydrogen as well, because hydrogen is a gas that's produced a lot. So you don't just produce a single hydrogen, you produce an H2. Bromine is the same way, chlorine is the same way, and so are the other 3 diatomics that I didn't list here. And then the third and final thing is you must always remember that the law of conservation of matter must be satisfied. Atoms cannot be gained or lost in a reaction. And that's what this whole VodCast is about is it's going to be dealing with this one law right here. And that law comes into play when we do balancing equations. Okay, just as a point of reference, the law of conservation of matter can also be referred to as the law of conservation of mass. And also to remember, that law means that mass cannot be created or destroyed. So that means you can't lose atoms along the way. Before we get into the various reactions, you need to be aware of symbols that are going to show up. Okay, we've already talked about the yield sign. Okay, so we have the arrow for the yield sign. But you also have this S, okay, and if you see that little S, and it will be located on the bottom as a subscript to an element, that means that that NaCl is a solid. Okay, if you see the L, that means that it is a liquid. If you see a G, that means that that substance is a gas. If you see AQ, that means it is aqueous, which means it's dissolved in water. Now, just as another quick point of reference, NaCl liquid and NaCl aqueous are two different things. Okay, you can have liquid NaCl. That means it's molten, it's pure NaCl. Or you could have NaCl dissolved in water, which is what this is. Okay? Now, some other symbols that you may see are on page 266 of your book, so go ahead and go look at those. But I want to point out a couple. You will oftentimes see an arrow with a triangle above it. That means that those reactants are heated. So that means that heat is added to it. So those are heated. Or if you see a yield sign with an element above it, like PT, that means that that reaction has a catalyst in it. Okay? So, a couple of different things that you will run across when you see different reactions. Now, this is from way back, but there are 4 indications that a reaction has occurred, and we are going to do a lot of reactions. So you need to pay attention and be aware of what those 4 indicators are. So, what are the 4 indicators? In no particular in no particular order, well, the first one is change in color. Second one is release of a gas. And remember, you tend to see this one as fizzing or bubbling when you see release of a gas. Release of heat and or light is another one. And formation of a precipitate is the last one. And we'll finally see that formation of a precipitate quite a bit in this particular chapter. Now, equations can be one of 2 types. They can be word equations or they can be formula equations. In the first couple days here, you will practice both of them. Okay, so this is an example of a word equation, and we can then directly change that to a formula equation by just substituting in the element symbols. So taking zinc, okay, we would write the element zinc, Zn, plus, go ahead and write HCl, hydrochloric acid, HCl. That is going to produce zinc chloride plus hydrogen. Now, This is a perfect example of an equation to show you that you need to make sure you write correct formulas correctly. Because if I wrote this as Zn plus HCl yields ZnCl plus H, okay, when I come to the next step, which is going to be balancing it, this may look balanced, but it's not known facts. So writing this way is absolutely 100% incorrect. So you have to write formulas correctly. So what we're going to spend the first couple days on here is the law of conservation of mass. Okay? In other words, we're going to look at balancing equations. This is something that you've done in the past. One key to remember when you're balancing equations is the number of atoms you have on one side of the yield sign must be the same as the number of atoms you have on the other side of the yield sign. Those must be identical. So, going back to this reaction, okay? As I start here, here's my one atom of zinc. Here is my HCl. Here is my zinc chloride, and here's my H2. So now, as I look at this, okay, I don't have the same number of atoms on each side. Sure, my zinc is okay because I have one of those on each side, so that's okay. But as I look at my hydrogens, okay, I have one hydrogen over here and two hydrogens over there. So what I need to do is get the same number of hydrogens on both sides. So one of the ways I can do that is I have to add a whole nother HCl molecule over here. Once I do that, now I have my two hydrogens that balance that. So now I have the same two things over there. And then just by doing that one little thing, okay, I also have the same number of chlorines. So that one little move also balanced out my chlorines. Oops, I went too far here, so I got to put that back up there. Okay? And so what I would do in my equation is I have one zinc. Okay, so I have one zinc, but we never write the number 1. 1 is always understood, so I'll never write that. I have two HCl's, so I'll put a 2 in front of that. I have one ZnCl2 and one H2, but I won't put 1s in there because those are 1 understood. So this number that I put right here is called a coefficient. Coefficients are whole numbers that are put in front, key, in front of formulas and indicate how many of those molecules or atoms are present. So the coefficient tells you how many of those are totally present. So I have 2 HCl's. And you notice I didn't take this HCl and write H2Cl to make it balanced because HCl is the correctly written formula, so you can't change the formula. Okay? And that gets me into my next major thing here. Do not change subscripts to balance an equation. Okay? I cannot put a 2 in here to balance out the H2, and I cannot put a 2 here to balance out the Cl2, because that changes what this formula is. So you can't do that. All you get to do, once you have correctly written formulas, is put a subscript in there. So let's look at another one, okay? This is a pretty big one, okay? And just to kind of look at my key at the top here, as you look at this color is aluminum, black is carbon, blue is hydrogen, red is oxygen. Oops, sorry. Okay? Now, this is not really what these look like, okay, as far as molecular geometry goes, but this would be my 4 aluminums and my 3 carbons. Okay? So I'm going to start with one of those. Then I'm going to start with 1 H2O, and I'm going to start with one CH4, and then I'm going to start with one of these critters. And again, this aluminum hydroxide over here, it really doesn't look like that, but that's just so I can get this done as far as how I want to do it. As you look at this, okay, and I want to start balancing, excuse me, one of the things you'll see is you have 4 aluminums over here, and I only have one, excuse me, one aluminum over there. So one of the first things I want to do is balance out those aluminums. So I'm going to need 4 of these things to do that. Okay? So those 4 then balance out those 4 aluminums on that first one. Now, one of the things I've just done though is I've created a whole lot of oxygen, red. Okay, but before I do that, okay, I have over here 3 carbons that I need to deal with, and I only have 1 carbon right here. So I'm going to take and put 2 of these up here. So that gives me my 3 carbons. And then I look and see, wow, I have a lot of blue and a lot of red over on this side. Okay, there's a lot of oxygen and hydrogen that's not balanced out over here. So that's going to be my next step, is to try to get those balanced out. Oops. I'm going to get this one back up here now. Okay, so I'm going to have to get a lot of oxygen. In fact, as you count here, I have 3 oxygens there, 6, 9, 12 oxygens. So over on this water side over here, I'm going to have to get 12 oxygens. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and I'll just leave that last one as my 12. That way I won't get confused. Okay, so now, just to double check, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 oxygens there. And I bet by doing that, I have enough hydrogens now. So if I count up my hydrogens, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I have 24 of these hydrogens over on this side. Now, do I have 24 over here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So, I have those balanced. So what I would do to balance this then is I would say that I have 12 H2Os, 3 CH4s, and 4 of those. Okay, so that's what you got to do, is you basically have to count atoms when you're balancing these things. Now, that's a lot of work to do that way, so I have a few tips that we're going to look at. Okay, first tip. When you're balancing equations, you want to balance the different types of atoms one at a time. And I'll talk about this more in a minute, but don't try to balance 2 or 3 atoms all at the same time. Just balance one atom one at a time. Secondly, if an atom appears in one formula on each side, try to balance it first. And what that means is, sometimes, like oxygen likes to be in 2 or 3 formulas, so it's not a good one to start with. The third one is balance polyatomic ions as single units, and I'll show you that. And the fourth one is balance hydrogen and oxygen last, if possible. It's not always possible. And the bottom line with all balancing is that it is mostly trial and error and being able to count. Okay? There's no real magic to this other than you putting in the time and the effort to actually do it. One last thing you need to know before we actually get into it is you must know the difference between a coefficient and a subscript. In this particular formula, this is a coefficient, these two are subscripts, and they do two different things. And you have to know what those are. This 2 means I have 2 of that entire thing. Okay? This 3 right here means I have 3 nitrogens, means I only have 3 oxygens. It has nothing to do with the nitrogen. Sorry about that. But this 2 means I have 2 nitrogens and actually 6 oxygens. So you need to know the difference between what those are. So if I were to take this and ask you, including this 2 in front, how many calciums are present in this, the answer to that would be 2. But if I asked you how many nitrogens are present, what is the answer? And that answer is 4. This 2 means I have 2 of those, and that 2 means I have 2 more. And then if I ask you how many oxygens there are, okay, that answer would be 12. And those 3 numbers were including that 2 in the front. Okay, so let's actually get into balancing. So here is an equation, and I would like you to balance it. The first thing you need to do in order to balance it is to actually write the formulas. And this is where if you don't write formulas correctly, you're going to have a problem. So, aluminum sulfate, Al2SO4 3. Calcium hydroxide, CaOH2 yields aluminum hydroxide, AlOH3 plus calcium sulfate, CaSO4. Okay? Now, I'm going to do the steps that I just explained to you. First of all, I'm going to balance different types of atoms one at a time. So I'm just going to pick this aluminum, and I'm going to balance it with what's on the other side of the reaction. And I have 2 aluminums over here, and I only have 1 aluminum over here. So I'm going to put a 2 out in front of this entire thing, because that means that I would have 2 aluminums then. Okay, so that takes care of that balancing. Then I'm going to go over to this calcium because I don't want to do oxygen. Number one reason I don't want to do oxygen is because it appears in multiple places. And that is rule 2. If an atom only appears in one formula on each side, try to balance it first. Okay, and that's a lot easier if you do that. So I don't want to do oxygen. Okay, so the next element I want to do is calcium. And as I look at calcium, I have 1 calcium right here, and I have 1 calcium there, so those are balanced. Great. Now, I have this sulfur right here. Okay, and I could balance that sulfur separately, but if I balance this polyatomic ion collectively, your life is going to be a lot easier. Okay, so I have an SO4 here, and I have 3 of them. And over here, I have an SO4, but I only have 1 of them. So what I'm going to do is put a 3 out in front of that, and that will give me my 3 CaSO4. But then I screwed up my Ca, so I'm going to go back over here and put a 3. Okay, so that's good. All right? And that's one thing to point out is once you sometimes balance something, you may screw it up balancing something else, so you have to go back and rebalance it. So then I want to look at hydroxide. Again, this is a polyatomic ion that I want to keep together. Okay, oh, I erased my 2 here. There should be a 2 there. And if I do that, in this case, I actually have 6 hydroxides. And if I look over here, I also have 6 hydroxides. So those are also balanced. So as I look at this then, my coefficients and right now are where they need to be. I have a balanced equation. This is 1. This calcium hydroxide is 3, 2, and 3. And we're balanced. Okay, let's look at another one. Let's look at this one. This is an example where we probably want to do this oxygen last. So what we'll do is we'll start with the carbon. I have 1 carbon, 1 carbon. Those are good. Okay, let's go to the hydrogens. I have 4 hydrogens, 2 hydrogens. That's not good. So what I want to do is probably put a 2 out in front of here. That gives me 4 hydrogens. And that actually was really nice because here is 2 oxygens, and here now is 2 more oxygens. So I have a total of 4 oxygens over on this side. And if I want to get 4 oxygens over here, what I can do is put a 2 in front of that, and then I'll have those 4 oxygens. And now that equation is balanced. Okay, let's look at another equation. Let's look at something kind of simple. Na plus O2 yields Na2O. Okay, as you look at this, some of these will be easy. You can get them by inspection. You say, okay, well, I have 2 sodiums here, and I only have 1 there, so I put a 2 there. Okay, be careful, because you're really not balanced yet, because you have 2 oxygens here. So then you go, oh, I need 2 oxygens, so the only thing I can do is add coefficient, so I better put a 2 there. But then that balanced your oxygens, but it messed up your sodiums. So now what you have to do is get rid of that 2, and you need to put a 4 there. And now you're balanced. So again, sometimes you change something and it will change everything else. But now that's balanced. Let's look at another one. Let's look at N2 plus H2 yields NH3. Okay, as I first look at this, I look at my 2 nitrogens. I have 2 on one side, and I only have 1 on the other. So my first instinct is going to be to put a 2 over here. Okay, now that balances those. And now as I look at my hydrogens, I now have how many hydrogens over here? And the answer is 6. So I need 6 over here. The way I can get 6 over there is by putting a 3 in front of that. And then that would be balanced. Let's look at another one. This one looks interesting. Fe plus H2O yields Fe3O4 plus H2. Okay? First glance, the Fe's aren't balanced. I have 3 Fe's here. I only have 1 here. So let's put a 3 out in front of this. Okay? Knowing full well I might have to change it. Okay? Go to hydrogens. The hydrogens are actually balanced. I have 2 and 2. So my problem is actually in the oxygen. I have 4 oxygens there. I only have 1 there. So if I put a 4 out in front of that, that gives me 4 oxygens. And as I look here now, I changed my hydrogen, so it looks like I have to put a 4 there. And that's one of the reasons why you actually want to do hydrogen last, okay? Because sometimes hydrogen and oxygen act as what I call a relief valve, and they'll let you do things on your own. So I believe that that's probably enough for balancing. You should be able to complete worksheet 1 and worksheet 2 after this VodCast. If you